Now proceed to sample problem number 4. A T-beam for a floor system has a slab thickness of 100 mm and a total depth of 550 mm. So yung total depth daw nito is 550 mm. It has a web thickness of 300 mm. So yung width ng beam natin dito is 300 mm. The T-beam is monolithically poured with the slab. So meaning to say, sabay yung pagbuhos ng slab at saka nung beam natin. The beam has a simple span of 6 meter. So given lang is yung span natin na 6 meter. Wala tayong given na clear span. And a spacing of 2.4 meter center to center. So from the center of the beam, ayan. So meron tayong center to center spacing na 2.4 meter. The beam carries a live load moment of 184 kilonewton meter. So we have M live load, 184 kilonewton meter. And a dead load moment of 84 kilonewton meter. We have a value of your F prime C which is equal to 20.7 megapascal, the value of your Fy which is 413.7 megapascal. And we're going to assume that our steel covering or from the centroid of your reinforcement, that is 65 mm. So 65 mm daw to. Determine the depth of the compression block, kakanapin natin yung A, and the value of the area of steel required. So from this, isosolve na ngayon natin yung values ng ng T-beam natin. And meron din tayong given na length ng span natin na 6 meter. Hanapin natin yung height ng compression block natin. And at the same time, we're going to find the value of your area of the steel. So for the T-beams, again, so for this one, yung first step natin is hanapin natin yung value ng BF natin. Since wala naman tayong given na value ng BF natin, we're going to apply yung mga formulas natin in computing for the value of your BF. So, etong mga beams natin na given, they are interior beams. So, let's say, eto yung mga yan. Ayan. So, mga interior beams yung dalawang yan. So, for this, hanapin natin yung effective width ng interior beams using NSCP 2015. So we have yung natin dito, yung clear span over 4 plus yung BW. So meron tayong span dito na 6,000 mm over 4 plus the width of your beam na 300. So you have BF which is equal to 1,800 mm. For the next criteria, number 2. So that will become yung BF natin is equals to 16T plus BW. So, 60 lang pala. O, tama, 16T. So, you have 6 times 100 multiplied by 300. So, BF is now equal to 1,900 mm. And lastly, BF is equals to yung mga clear span natin dito. So, for this, meron tayong center to center spacing. So, yung width ng web natin plus yung spacing natin, 1 over 2 plus yung clear distance natin from face to face of your column over 2. So, paano yan, sir? So, BF is now equal to, so since interior column to, kung 2.4 yan, 2.4 din yung kabila. Kasi meron tayo dito, ibig sabihin continuous yan. So, we have yung BW natin na 300 plus yung clear spacing natin. So, from the face of your beam to the other face of your beam, so 2,400 mm minus kalahati ng 300, meron tayong buong 300 over 2 plus 2,400 minus 300 over 2 para dun sa kabila naman. So consider natin etong beam natin na interior dito. So yung kalahati dito, eto yan. So you have the value of your width of the flange which is equal to 2,400. So therefore, considering yung natin, first step natin in computing for the value of your width of the flange, so hanapin na ngayon natin yung value ng BF natin. Sir, what will be the value of your BF? That will be the smallest value natin. So meron tayong 18, 19, 24. So BF is now equal to 1,800 millimeter. So with that, so this is 1,800 mm. So ngayon, after natin makuha yung BF natin, for the next step, check if true beam. Paano natin i-check kung true T-beam yan? So we are going to assume, so diba, ina-assume natin dito na A is equals to TF. And then kinukuha natin yung value ng C sub F natin and the value of your T. Tapos pagko-compare natin yung dalawa. Yung C sub F natin, yung formula natin is 0.85 F prime C. So yung area ng flange natin. Yung T naman, that is AS, tapos FY. Kaso nga lang yung problema dito is hindi natin magagamit tong formula na to. Bakit sir? Kasi hinahanap nga yung AS natin. So kapag ganun, we will going to refer dun sa values natin dito. So let's say, gamitin natin yung mga given natin. Meron tayong given na service moment na live load na 184, sa dead load naman is 84 kN meter. E di kunin natin yung MU natin, yung ultimate moment capacity natin. So you have 1.2 MDL plus 1.6 MLL. So yung DL natin, that is 84 plus 1.6 LL natin na 184 kN meter. So you have a value of your MU which is equal to 395.20 kN meter. So ito yung dadalhin ng beam natin. So for that, yung tanong kasi dito, since meron tayong T-beam, yung tanong is, what will be the value of your height of your compression block? Kung hanggang dito lang ba siya or lalagpas siya dito sa thickness ng flange natin. So kapag moment yung given, hanapin ngayon natin yung moment dun sa flange natin. Yung ultimate moment natin kapag kinonsider natin that A is equals to T sub F. So with that in mind, hanapin natin yung moment natin kapag yung A natin is equals to TF. So sir, paano po yun? So yung compressive force natin, it will act dito sa region natin sa flange. So you will have MUF, that is the reduction factor, multiplied by NNF. So para makuha natin yung nominal moment natin sa flange, so that will become yung C natin multiplied by, so yung moment arm natin, so lagi tayong mag-moment dito sa tension, so that will become D minus, so meron tayo dito, gagawin natin yan is, we will going to consider na eto yan. So nandito yung natin, tension natin. Tapos meron tayo dito na moment. So yung we assume na yung A natin, that is equal to 100. Ito na ngayon yung C natin. So meron tayo from T hanggang doon, that is D, or the effective depth, minus A over 2. Yung A natin, that is the thickness of your flange, over 2. So hanapin na ngayon natin yung value ng nominal moment natin sa flange. So that will equal to 0.85. So C, that is 0.85, F prime C. So ano yung value ng F prime C? That is 20.7. A, so yung A natin, that is equal to 100. So yung B natin dito, that will be the base ng flange natin. So yung area natin dito sa compression, ito yung area natin sa flange, which is equals to 100 by 1,800. Multiplied by the moment arm. So your effective depth, that is 485, minus yung A natin na 100 over 2. So you will have a value of your nominal moment sa flange, which is equal to 1,377.69 kilonewton meter. So for that, kunin natin yung MUF natin. Sasabihin natin na assuming na tension control tayo. So, multiplied by the nominal moment. So, makukuha natin that your MUF that is equal to 1,239.92 kilonewton meter. So, with that, di ba yung principle natin dito is kailangan mag-balance yung mga values sa moment natin, yung mga values sa compression natin, at saka sa tension. So with that, kung sa naunang problem, kinompare natin yung CF at saka sa T, dito naman, we are going to compare yung MUF natin at saka yung MU na na-compute natin. So yung dadalhin ng beam natin, that is only 395.20 kilonewton. Tapos, yung MUF naman natin, na kapag kinonsider natin yung flange natin, that is 1,239.92 kilonewton meter. So, pagko-compare natin yung dalawa, so yung MUF natin, yun yung moment. Kapag kinonsider natin yung compressive force natin, it will act dun sa thickness ng flange natin. So, with this, pagko-compare natin sila, since yung MUF natin is greater than to the value ng MU natin. Therefore, ano tayo? Not true T-beam, not T-beam. Sir, bakit po ganon? Kasi hanggang sa flange lang ha. Hanggang sa flange lang. Yung moment niya is 1,239.92. Samantalang yung dadalhin lang naman ng beam natin is 395.92. So meaning to say, less than sa value ng TF yung value ni A. Again, kapag kino-consider natin yung flange natin, kapag kinukuha natin yung moment, the more na lumiliit yung value ni A natin, lumiliit yung value ni MUF natin. So for that to happen, para mabalance natin silang dalawa, paliitin natin yung value ng MUF natin. So, paano natin paliliitin yan, sir? Di, paliitin natin yung value ng A natin. So, therefore, kung hindi true T-beam yan, the value of your A, that is less than TF. And with that, masasabi natin na T-beam. So, meaning to say, we will just consider yung beam natin as a wide rectangular beam. Or kung paano natin kinonsider yung singly reinforced beam natin. So, yung ano lang naman dito, yung SRB analysis natin for rectangular section lang. Yung gagamitin natin. Okay? So, with that, hanapin na ngayon natin yung value ng, so, under case 1 tayo dito. So, hanapin na ngayon natin yung value ng A natin. So, for the step letter C, so, MU, that is equals to rho, nominal moment. So, we have rho C multiplied by D minus A over 2. So, ganun lang kasimple yung approach natin in computing for the value of your A. So, let us now use yung mga formulas natin. So, yung MU natin, yung dadalhin lang naman, nung beam natin is hanggang 395.20 kilonewton meter. So, kung insert natin sa formula, times 10 raised to 6 para maging Newton mm. So, we will going to assume na ano dito, tension control tayo ha. So, assume rho is equals to 0.90. So, mga 0.90 multiplied by 0.85. Yung F prime C natin, we have 20.7. So, hahanapin natin yung value ng A multiplied by the width. So, yung magiging width natin, that is 1,800. So, multiplied by yung moment arm natin na 485 minus A over 2. So, the value of your A, that is equal to 29.48, which is less than to the thickness of your flange na 100 mm. Therefore, wide rectangular beam. So, yung analysis natin is nasa case 1 tayo. So, with that, eto na ngayon yung value ng A natin na naka-millimeters. Hanapin natin yung C. So, that is 29.48 since NSCP 2015. Tapos, 20.6 lang yung F prime C natin. So, the value of your beta is 0.85. So, C is now equal to 34.69 mm. So with that, kapag nakuha natin yung C natin, proceed tayo sa next step. Check if assumption is correct. If correct. Check assumption if correct. Sir, paano po natin gagawin yon? So all we need to do is to compute for the value of your Fs 600 multiplied by yung D natin na 485 minus yung C natin na 34.69 over 34.69. And the value of your Fs is now equal to 7,788.58 megapascal, which is greater than Fy, therefore tension still yields. And for the last step, in computing for the value of your As, so C is equals to T lang tayo. So we have 0.85 F prime C, AB is equals to As Fy. Nag-yield yung bakal kaya Fy. So we have 0.85 F prime C natin, that is 20.7 multiplied by 34 multiplied by the value of your A, which is equal to 29.48 multiplied by the value of your B, which is equal to 1,800 equals As multiplied by Fy na 413.7. So the value of your As is now equal to 2,256.86 millimeters squared. So this will now become your answer. So ganun lang kasimple yung pagkuha natin sa area ng steel natin considering wide rectangular beam.